Hey guys, welcome to our third threat hunting session. My name is Alexey Firsch. I'm security engineer at VirusTotal. And in our previous webinars, we already covered VT intelligence and VT hunting parts of our service. So this time we're gonna talk about API tricks. As I remember, there were many folks were interested in this. So at VirusTotal, we are constantly working on providing our customers with the most suitable tools to operate with our data. However, it's still impossible, to cover all the use cases. That's why we have an amazing API that you can leverage to build literally your own version of VirusTotal with the features that make sense only for your cases. And yeah, that makes a lot of sense actually. When I was working on malware research, there were guys who tried to create an IOCs processing system, and I remember they were struggling with the GUI approach because it was absolutely impossible to fulfill everyone demands, because for Android analysis team you need to visualize specific set of data, and for the Windows analysis team, for instance, this data set is completely different. That's why they just implemented a basic set of UI frames, like tables, and they provided everyone with API to the backend systems, and that's pretty much it. So everyone can make their own version of workspace in JavaScript using this API and these frames for their specific needs. And that was a win-win case for everyone. So back to VirusTotal, in some cases you just need to have a quick integration with VirusTotal and your existing internal systems. In some cases, you might want to have a quick, handy script that can bring you the specific set of data from VirusTotal. Imagine you're working on on stream of samples, and you can run the script on every sample that you're working on to get specific file properties or submission data or relationship details like CNC address or in the well distribution host. And yeah, literally you can do it in one click. So we already have a couple of official integrations for CMs like Splunk and CrowdStrike, for example. It works straight out of the box, and you can also face with the cases when you need to perform the same queries on a daily basis, and for example grab the samples by specific query and then send them for further processing. So you can automate that kind of things with API. Literally everything that you can do with VirusTotal website, you can do with API. Even manage your YARA rule. So if you want, let's say if you want to deploy your YARA rule in all the platforms in one click, imagine you have some internal YARA system, internal YARA scanner, and you want to just, compose your YARA rule and press the one button and deploy your YARA rule in your internal system and in retro hunt and live hunt at the same time. This is something doable with API. And the case we are going to cover today is implementing a dashboard to track specific threats. So we already mentioned during our previous session, to demonstrate how powerful VirusTotal API could be, we implemented a dashboard that allows you literally to track APT actors in VirusTotal data sets. I think you can find the overview of this dashboard in our last session. So I don't want to repeat this review once again because it's quite complicated. There are lots of code to get it from the first site, especially if you're not familiar with VirusTotal API. So instead of this, I prepare a couple of exercises on exactly the same techniques I used during this dashboard implementation, but let's say in a more flexible way, so you can employ these techniques for your specific needs. So this will be sort of workshop, and I know that it's hard to deliver such things online, but yeah, I'll try to do my best to keep you guys involved into the process. So I'm going to use Colab. It's a Google version of Jupyter Notebook, so it's public. You can use it as well. If you're familiar with Jupyter, it will be super easy for you. If not, don't be afraid. You can do the same stuff with your local interpreter. It's just literally the Python in the cloud. So in order to optimize your experience, you can also use client libraries such as for Python and for Go, and we're still working on Java version. There's also lots and lots of third-party scripts and clients maintained by community. So libraries for Python and for Go developed by VirusTotal guys, and apart from it, there are lots of different scripts for different languages. You can even find Maltiga transform here. So, and also we have an incredible documentation. Of course, I'm a bit biased here, but this is something incredible. It's not only covering your regular questions like what is the file object, with this extensive description with list of every file attribute, and the same to search endpoints. For example, this one, advanced corpus search, is the endpoint that basically covers 90% of the real life use cases because it corresponds with VTI intelligence. So you can do exactly the same thing that you're doing with VirusTotal website. So let's say we are looking for ISO files with delivery in its names. I can order the output, depends on the type of entity that I want to get. So in this case, it will be files. So just give me the most, the recently submitted files. Then I can put the my API key, and you see this chunk of code. It's already developed. We can just copy paste it in our project. And the good thing is that we have plenty of languages here. So again, it's already in place. We can just copy paste, and you can even run it right here and to get the result, to see how it looks like. So you can get back to your project to parse all these properties and stuffs like this. So let's jump into the action. Let's jump into the action, into our Colab. At first, I'm gonna use a couple of dependencies here. I'm gonna install a couple of dependencies. I'm gonna use our VirusTotal client for Python because I'm a big fan of it. It literally makes your life much easier. Then we have this Nest Async IO. It's only just for better compatibility. So VirusTotal client is using async calls, so we need to maintain it. And let me just rerun this cell. It's already installed. Everything's fine. So the next cell is all about the imports, and we have this nest async apply. That's pretty much it. That's did the trick with this async calls. And I'm going to initialize VirusTotal client with this by using my API key that I previously set as an environment variable. Let me rerun it just in case. So yeah, our first exercise. So what I did is I made this block charts that corresponds with the code that we can see here for, to better visualize this, what is happening here. So the first case is super straightforward. We're just gonna use VTI intelligence query to get the list of file objects, and then we're just gonna print SHA-256 attribute. So again, you can always refer to the documentation to check out the full list of these properties to find the most relevant for you, to find the ones that you are interested in. So yeah, as I said, it's exactly the same thing as you're using on the website. So basically, I can use VirusTotal pop-ups to make this query, and I'm gonna use this engines search modifier to get files detected with Lazarus verdict or with Blue North verdict, and let's give this a try. Yeah, that's pretty much it. So let me just copy paste it to our collab, and you see this client iterator. So basically this is the method that we are using when we're expecting to get the list of objects, not the single VirusTotal object, but the list of objects. And it's not literally the Python list. You can iterate only once. So I'm gonna transform this to the Python list just in case, so we can use it afterwards. And for the first argument, we're gonna use this endpoint. Again, you can find it in the documentation over here, intelligence search. The second argument is parameters, and again, refer to documentation. You can see all parameters here, our query and the order that we prefer to order our files, and we can also limit the output by only 10 files. So let me just run this query, and boom, we got these files. And just to double check that they are literally related to, yeah, I can see it. We have a Lazarus detection. So as the next step of this exercise, let's try to beautify this output a little bit. We just print SHA-256 attribute that's not super informative. Let's try to get more properties, more context on these files. So what I'm going to do is to convert the list of the file objects that we got here to Panda data frame. Pandas is super popular data analysis tool, and it's super handy to operate with this. So what I'm going to do is I'm going to process this file object attributes in like custom way. I'm going to fetch SHA-256, type description, first submission date, and last analysis results. So you can also again refer to documentation and find this attributes over here. So for last analysis results, I'm gonna filter out irrelevant and AV verdicts, and I want to keep only those that contains Lazarus or Blue North. Yeah, that's pretty much it. That's exactly what this function does. And for the rest of the properties, like for SHA-256, for type, and for fast submission, I'm just going to keep type distribution as it is in this file object. And for SHA-256, I'm going to, to transform these properties into the beautiful hyperlink to get this ability to jump to VirusTotal directly from Colab. And for fast submission, I'm going to convert the timestamp to just datetime object. And let me run this query to get the output. And yeah, we can see much more context over here. It's way more handy than just print SHA-256 list. And again, you can just jump to VirusTotal and verify your findings. Yeah, it's definitely something Lazarus related. Moving on to the next exercise. Here we're doing exactly the same thing, but instead of listing files, we're going to list collection objects. And again, this is something that you can find in the documentation with detailed description on all the object attributes. Let me just close a couple of tabs. So again, the first cell is pretty straightforward. It's exactly the same as the previous one. So we're just gonna use VTI query. Then we got this list of collections object, and we're just gonna print name and ID properties from these collection objects. So let's try to compose once again the query, and I'm going to VirusTotal once again. And this time we are looking for collections, right? And I'm interested only in collections that contains Lazarus or Blue North in its names. There is also a tag attribute for collections, so this is something we can also use. Yeah, that's pretty much it. So we can just copy paste our VTI query here, and let me run this cell. And yeah, we have this output. We have collection name, we have collection ID that we're gonna use a bit later. And let's see what we're going to do in the second part of this exercise. So once again, we're collecting the list of these collection objects to pandas data frame. Then we're going to convert some of the attributes, some of the collection attributes to hyperlink, like name and ID. And we're going to process the rest of them, like targeted regions, targeted industry, and a couple of dates. And then we're just gonna print this collection attributes. Let's see how it looks like. So again, no rocket science here. Here's the timestamps that we are converting to date time. And for targeted industries, targeted regions, we're just gonna print it as it is. And again, we're doing this magic with conversion of ID, collection ID, and collection name to this hyperlink that can lead us to VirusTotal. So yeah, we don't have any targeted industry, unfortunately, here. So let me just, out of curiosity, change my query we're still looking for collections, but let's say we are looking for collections that contain targeted industry, let's say banking. And let me rerun this as well. Yeah, that's more informative. Targeted industries, targeted region. But let me just get back to the Lazarus. Whoops. As our next exercise is also related to collections. So what we're going to do in this third exercise, we're going to fetch the file objects from collections that we just got. So, you know, I got this list of collections, and now I want to get the most recent files that were added to these collections. Sort of recent IOCs related to Lazarus. I have to rerun this once again. Yeah. And to do that, there is a specific endpoint. This one. So in fact, you can use a regular VTI intelligence search to extract collection entities, but the trick with this endpoint is not gonna use your VT intelligence quota as far as I remember. So yeah. And on the next step, as we got this list of files, we're going to sort all of these files but by their first submission date and remove the duplicates to get this list of certain IOCs. And let's see how it looks like. So we have this collections that we previously got here. And we're going to process this list. We're going to use this endpoint collections collection ID search. Again, yeah, this one. To fetch only files with specific order, and yeah, we're just interested in like 20 most recent files. The next step, we're going to remove non-unique files, non-unique entities, and then we're just gonna sort this list by first submission date to get the recent files. And in the end, we're going to print, SHA-256 of these files. Take some time because basically it performs number of searches, depends on the number of collections. So again, we can check in VirusTotal. Yeah, it's related to Lazarus, and yeah, it's quite recent. So in the next exercise, don't be afraid, it looks complicated, but in fact it's super simple. We're doing exactly the same thing. We're just going to fetch not only file object, but we're going to fetch IP addresses, domains, and URL objects from these collections. The only difference is that you need to use different attributes to sort these objects, because, for example, there is no first submission date for IP addresses. It's only relevant to file object and URL objects. So yeah, it looks exactly the same. I just replaced this with argument variable, and yeah, we're just doing this extraction for domains, IP addresses, and URLs. And we're going to print this object over here, and just to remove, just to avoid this row URLs. Let me run this cell. Yeah, and the thing that you can get from here, so there's ID property, and for file, ID is SHA-256 of this file. For IP address, ID is the raw IP address, and for domains it's the same, it's the main name. But for URL objects, we definitely cannot use the URL itself. We're using SHA-256 of this URL string. So instead of printing URL ID, we're gonna print URL property. And yeah, you can see that we started with files, then we got IP addresses, domains, and URLs. And yeah, we just extracted this IOCs from that collections. The next exercise is about relationships. So relationships is a crucial thing to understand how VirusTotal API is working. So every VirusTotal object have some links, relationships with other objects. Let's say we have collection object, and there are a bunch of files, IP addresses, domains linked with this collections. Let's say we have a file and another file that was dropped during the execution of the first file. They are linked with each other with these relationships. File distributed from specific host, they again link it with each other. And for every object, you can check out the list of available relationships, you know, the contacted domains for this file, analysis, behaviors, etc., etc. And yeah, what we're going to do is we're going to use previously fetched the list of file objects, this one, and we're going to regularly, as we just did, process a couple of file object attributes. But here the magic happened. We're going to jump from file to list of related collections, and then we're making yet another jump from collection entity. We jump into user object, which is basically the owner of this collection. And we're going to print the properties of this new object that we just fetched. So let's see how it looks like. Yeah, so here's the file properties, right? First submission, type, name, MD5, SHA-256. But here we are creating a temporary column collections, you know, to fetch all collections linked with this specific file, with each file. And then we're going to process every collection. We're going to process the properties. We're going to process ID, name to create this href that we just did with files. And we're going also to process last modification date of the collection object. And we're going to perform yet another jump from collection to the owner of this collection, to the user object. And we're going to fetch first name attribute. And again, guys, you can find all of these properties here, and you can find all relationships, you know, in our documentation. Again, jump to the user, first name, This is the thing that we are going to print. And let me run this query. I'm gonna switch to the slides so you can check it out once again. So yeah, this relationships jumps is something that you can simply learn, and you can use it in every related case. Yep, so we just got this beautiful table, and you can see we have this list of previously fetched files. We have file properties such as name, type, submission. We also have collections list linked with these files that we just got with this relationship. And we have this list of authors of this collection. We just also use relationship to get it. And let's just refer to this one. Well, it's better to start with the file. Yeah, and you can navigate to community, and you see a bunch of collections here that we listed in the table. Yeah, that's pretty amazing because you can do the same stuff with the rest of IOCs. You can do the same thing with IP addresses, with domain, with the URLs. You can fetch the properties of these objects. You can, find some useful relationships to another object, fetch them, and then fetch their attributes. It's like never-ending story. Whatever you found useful for this case, for your case. So the next exercise, pretty straightforward. We are starting from the beginning, so we're not going to use previously fetched lists. In this case, we're going to use VT intelligence query, again, to list file objects detected by specific crowdsourced rules. And again, we're just going to print SHA-256 attribute. We're going to use this complicated VirusTotal intelligence query. Let me remove single quotes here. Yeah, you can see we just got the files detected by some YARA rules related to Lazarus or Blue Norov. So again, we're using the same endpoint, super straightforward, pretty much the same stuff. Let me run this cell to get the list of SHA-256. Yeah, cool. So, and now we're doing the same trick. We're going to beautify it a little bit, but this is just the first step. So there are, for file object, there are interesting attributes such as crowdsourced YARA rules, crowdsourced ideas, results somewhere here. And we can leverage this in our table, to get more context on this list of files. So with the first approach, I'm just going to print all these properties as it is without additional passing. And yeah, I'm going to, as we just did before, I'm going to process this file properties as well. File properties and this crowdsourced related attributes. And let me run this query. It looks a bit messy because you can see we didn't parse it. We just print the entire data structure, and now we can play around with it. We can find the data that we're interested in. For example, I'm not interested in the rule set ID. I'm interested in rule name, maybe in a source, in a description, stuff like this. So what I'm going to do is I'm going to build a custom parsing for all of these data structures. And yeah, it's not the same graph as we have here. It's not the flow graph, but it just shows the relationship of this file object with these properties. So for crowdsourced YARA results, we're going to fetch rule name, rule set name, description, source, and author. And you can see the same for Sigma and ideas. So the code itself looks complicated, but yeah, I'm not gonna jump into the deep description of all of this, because it's doing pretty much obvious stuff. I'm just checking the properties like this rule name, rule set name. For aliases like Lazarus, Blue, Nora, from just APT, I'm not interested in the other rules. I just want to print the ones that I'm interested in, and yeah, that's pretty much it. And you can see the regular properties here, and we apply this custom function to build this custom processing of these properties, and this looks way better. You see, we have the rule name, we have the author, and we have even a link to repository with the YARA rules. Moving on to the next one. It's actually related to the thing that we just released recently, Crowdsourced YARA Hub. So Crowdsourced YARA rules is not a secret anymore. You can browse through it. You can build additional search here. Like I want to check all the rules from Kaspersky, specific malware name, some sort of dates, filters. I'm gonna use this, and yeah, you can do exactly the same thing with API. So there is an endpoint, and you can list YARA rules here instead of just list the files detected by this YARA rules. And what I'm going to do is just to get the list of these YARA objects, and I'm going to print some of its attributes. Yeah, you see a different endpoint. It's not the VirusTotal intelligence search, it's YARA rules. And we're going to use this filter to get only Bumblebee related YARA rules. We're going to print name, author, and let's comment the rule at first to keep only meta. So meta is actually attribute related to meta section in YARA rule. So you can parse it, you can extract the things that references or author or even description. So this is exactly what I did with description. I'm going to extract description from the YARA rule itself. And yeah, you can also print the rule over here. It's not gonna, it doesn't look good, but in some cases you might want to. The graph listing is also super custom thing. We're not going to use VT intelligence. We're going to use the specific endpoint related to graphs. And yeah, super straightforward, getting the list of these graph objects, and we're going to process and print a couple of its attributes, such as name and description. Let me navigate to graph object. Yeah, you see? graph data, description. This is exactly what we're going to use. Different endpoint. This is our query. Again, we're looking for graphs with Lazarus in its name or actor Lazarus. And we're doing, again, the same magic to make a hyperlink here to VirusTotal using graph ID and the graph description. Let me run this cell. And yep, you can see the list of the hrefs. You can jump to VirusTotal to check out this graph. So the last but not least is related to comments, and this is super important thing. I found it super important because it's like yet another approach to find malicious activity. So this way we're not gonna leverage AV vendors, we're not gonna leverage our crowdsourced rules, but instead of this we're going to use the comments. And for comments, sometimes we have something really cool. For example, let me just show you in VirusTotal. So here we are looking for files with Lazarus in comment and Thor. Thor is actually related to Tor APT scanner. And this is kind of another way to detect these files because they maintain their own repository of these detection rules, and every time they match something they put in this comment. So yeah, we can use it to get Lazarus related files. This time we're going to use, again, VTI intelligence endpoint, and just going to print the file ID, which is SHA-256. And to beautify this, we are doing, again, this jump magic. So at first we're going to fetch the comments related to this file by relationship. So as you may remember, there is a comment relationship that can lead you to a list of comments on this file. And then we're going to process comment object to extract the date from this object, and from comment object we're going to jump to the user object to get details on the author of this comment. Let me run this, so it can take some time, so it's better to run it right now. So again, this is exactly what we have seen before, the regular file properties, and here we are getting the relevant comments. Again, I made a custom filter here to filter out all irrelevant results, to keep only ones that contains, you know, Lazarus or Blue Nerve in the comment. And we're doing another jump to get the comment author. We're using this relationship endpoint, and we're doing this href out of author ID, you know, to jump on its profile in VirusTotal. Let me just verify real quick. So we have this file, and basically it have to contain, yeah, lots of comments that probably contain Lazarus. Or Blue Nerve. No, only Lazarus. Okay. So, yep, that's pretty much it. on API thingy. Hope you guys like it, and you got this vibe of unlimited power of what you can do with VirusTotal data. And that could be the end of this talk, actually, but it's not, not yet. As you may know, AI is everywhere nowadays. AI-powered antivirus, AI-powered service, AI-powered toaster. So we just can't miss this opportunity and release something AI-related. But yeah, jokes aside, it's called Code Insight, and it's like having your pocket analyst. Provides you with, yet another way of detection of malicious activity. It's only our first approach and still under development, and works only for limited types of script files. So I'm not expecting, the big impact right nowadays, but I can see it as a game changer in the near future. So basically, Code Insight is a short file description generated by LLM. So you can see it in a file description in a detection tab. But let me just jump to VirusTotal. You can also use search modifier. To look for substring in this description. So I'm just gonna use, malicious. And you see, works mainly for PowerShell. Yeah, we have JavaScripts over here. Remote server could be malicious. Yeah, so it ain't much, so we can use Code Insight with have keywords. So basically it works only for the newly processing files, right? We're expecting to get much more in the near future, but now it's only 15K. So the good news is that you can combine this Code Insight with any other search modifier. For example, let's say we're looking for something malicious, but at the same time not detected by any other vendor. And I don't know, let's put something delivery maybe, or backdoor. Okay. Yeah, so backdoor PS1, okay. This file detected only by 4 antivirus vendors, but we can see extensive description by this Code Insight. Shows that, yeah, it most likely malicious file. You can also use, like, I don't know, Cobalt. You see 0 detects, but in fact it's sounds like Cobalt Strike. Yeah, Cobalt Strike updater. Oh, okay. And this one is a Cobalt Strike beacon. Again, 0 detection so far. So yeah, stay tuned for the newest features. We will be working on this, and I hope you will have much more soon. That's finally pretty much it from my side. Thank you very much, guys. Thank you for your time. Let me just check the questions. So there are lots of requests on sharing the collab. guys, I don't think I even allowed to share this specific collab, as it was like created internally at Google. Yeah, but given the high interest, yeah, we'll try to find the way of sharing this code. And yeah, we can notify all participants by email. Yeah, but please keep in mind that the main target of this talk is just to show you an approach rather than provide the code for just copy pasting. So the next one, is Code Insight only for Windows PowerShell, no Mac Linux? I don't think there is a like platform restriction, to be honest. So it should be fine. Oh, how can I best employ VirusTotal to help detect and rescore potential or otherwise verifiable malicious domain abuse or type of squatting issues for several thousands domains of interest? Wow. That sounds like a case where you can use many different approaches. So my short answer is try to first analyze the context that VirusTotal can provide you on these domains of interest. So you can just go to API and look at domain objects. So you can analyze all these properties. Like, I mean, the most relevant for you is probably last analysis results, where you can check the verdicts, category. There is also, I think, reputation could be useful, popularity ranks, like to filter out all legitimate domains, super popular ones. Is it possible to fetch specific parts of the content via API? That sounds like an overkill to me. I'm not sure what's your final target, but you can use the content search, like with VirusTotal Intelligence. Something like send text message. So you can do this with the API to list the file objects, and then you can use a certain endpoint to download the file, and you can then programmatically like pick the interesting offset locally, if it makes sense. Can you give us the links to watch the previous two videos? So you can actually click on Google Cloud account on BrightTalk, and you can scroll and find this. I think it's called Threat Hunting with VirusTotal. There is also a YouTube account in VirusTotal. Yeah, there is also a YouTube account where you can grab all these tricks. I think Threat Hunting is over here. Yeah. So this is the first one. And that's the second one. When you say Code Insight only operates on scripts, do you mean any samples where the code isn't compiled? Not exactly, because it's kind of limited. We started with PowerShell only, then I guess we added VBS scripts as well and JavaScript. Again, we're working on this like nowadays, right now, and there are lots of updates. So I think we just published the blog. You can also check blog.virustotal.com. Yeah, this one. So I think this is the recent details that we have. Is Code Insight available via API? Yes, absolutely. You can use this Code Insight search like with the regular VirusTotal Intelligence endpoint. Yeah, with this one. Is code inside automatically leveraged when uploading samples? Yeah, but as I mentioned, only for specific files, only for specific formats. Does code inside get Q&A in case its assessment is incorrect, or it's just a raw dump of what AI thinks? Yeah, we have a couple of checks. So we're trying to validate this output, but as you can imagine, it's tricky. So yeah, as I said, it's just the first approach. So yeah, could be some mistakes. I think this is pretty much it. Thank you guys very much for your time, for visiting us. See you next talk.